Hey everyone, welcome back. This is lesson 6-5, part C. This is the third video of a 4-part series on finding real roots of polynomial equations. So far we have used factoring to solve a polynomial equation. Remember, that means we are setting the function equal to 0 and then solving for x. Example, if we are asked to solve a polynomial, the following polynomial equation, f of x equals x squared plus 3x minus 4, we would first set the function equal to 0. So once we do that, then we can say x squared plus 3x minus 4 can be factored, and I like to factor this way. What two numbers multiply together to get negative 4 add together to get 3? Well, I know that is 4 and negative 1. So 4 times negative 1 is negative 4, and 4 plus negative 1 is 3. So I know that 0 equals x plus 4 times x minus 1. And in order for that to be true, either x plus 4 equals 0 or x minus 1 equals 0. If x plus 4 equals 0, then we know x must be negative 4. And if x minus 1 equals 0, then we know x must equal 1. Since this is a quadratic equation, and we know that because our highest exponent is a 2, we can say when y is 0, x is either negative 4 and x is also 1. We know this is a parabola, and this is a positive here, so our parabola is going to look something like this. And we know that negative 4 and 1 are the roots of this equation, because that's where the parabola crosses at the x-axis. So let's review factors real quick. I just want to remind you back like what you learned probably back in 4th, 5th, or 6th grade when you had a question that said factor the number 36. You would write 1 and 36, and then you probably wrote 2 and 18, 3 and 12, 4 and 9, and 6. And all of these numbers are the numbers that will go evenly into 36. If you divide 36 by any of these numbers, you're going to get a remainder of 0. So remainder is going to equal 0. And same with the factors of 54. If we did 54, we would say the factors are 1 and 54, and 2 and 17, and 3 and, 2 is not 27, it's 27. Sorry about that, let me change that. 2 and 27, and 3 and 18, and 4 doesn't, 5 doesn't, 6 and 9. And there's all of our factors. And again, the key thing is that they all have a remainder of 0. So we're going to take that information, just want to remind you that these numbers each of these numbers are factors of 54. Let's take a look at this function. If we're asked to solve this function, we would want to factor it. And the first thing we would want to do is go ahead and set it to 0. So let's change this f of x, we'd set that to 0. And then looking at this, I see I have a 4x squared in each of these terms. So I can divide each of these terms out and actually factor out a 4x squared. And that leaves me with x squared minus 4x plus 3. I can continue to factor this next part. Say what two numbers multiply together to get 3, add together to get negative 4, and I know that's negative 3 times negative 1, because negative 3 times negative 1 is a positive 3, and negative 3 plus a negative 1 is a negative 4. So in the end, my factored out problem would be 4x squared times x minus 3 times x minus 1. Okay, so I want to talk about how we could go back and prove that this x minus 3 is really indeed a factor of this problem here. And so what we can do is our synthetic division. So let's remember what we did with synthetic division. We could put our 4 and then our negative 16 and a positive 12. All right, and let's go ahead and divide by this x minus 3. piece. And when we're doing synthetic division, we just say what number is going to make this whole thing 0, and that would be a positive 3. So I'm going to put a 3 there. Now remember, in synthetic division, we just bring our 4 straight down. 3 times 4 is 12. Negative 16 plus positive 12 is a negative 4. 3 times negative 4 is negative 12. And notice that we get a 0 for our remainder. So we know that this is correct. We could also try it with our negative 1. I'm just going to erase through here. And let's do it again with our, for our x minus 1. Again, we try what number would make that a 0, and that's going to be 1. So let's multiply through. Bring down your 4 straight down. 1 times 4 is 4. Negative 16 plus 4 is negative 12. 1 times negative 12 is negative 12. 12 plus negative 12 is 0. So once again, my remainder is 0. So I've checked that both of these are indeed factors of this long function. All right, let's try one more. Okay, so in this function, we're asked again to solve, and so the best way to solve is by factoring. The first thing I want to do is let's go ahead and factor out a 3, because 3 can divide into each of those terms evenly with a remainder of 0. So we're going to take that out, and that leaves us with x to the 4th minus 6, not 6 anymore, 2x squared minus 8. All right, so once we have that, we could actually factor this, but I want to try doing some division. I want to find out if, let's say, x plus 1 is going to be a factor of this function right here. So what I'm going to do is do my synthetic division. And so in order to do the synthetic division, I'm going to look at this x plus 1. I'm going to say, what number would make that 0? Well, that would be negative 1. All right, and I'm going to go ahead and divide by negative 1, and I'm going to use this piece right here. So my coefficients is going to be 1. Now remember, we have to keep our x's, x to the 4th, x third, x squared, x, and then our constant. And so I don't have any x to the 3rd, but I need to keep a placeholder, so I'm going to go ahead and put a 0 there. And then I have a negative 2, and I don't have an x, so I'm going to have a 0 for a placeholder for my x, and then a negative 8. All right, so now that I have my numbers, I'm going to go ahead and divide by negative 1 using my synthetic division, so I'm going to bring the 1 straight down. Negative 1 times 1 is negative 1. Add those together, I get negative 1. Negative 1 times negative 1 is positive 1. Add those together, I get negative 1. Negative 1 times negative 1 is positive 1. Add them together, I get 1. And negative 1 times 1 is actually negative 1, so I end up with negative 9. Now that is not a remainder of 0. So what that tells me is that x plus 1 is not a factor. So I'm going to erase all this, and I'm going to try something else. Okay, so I'm going to try and keep my original problem up there. So this time, let's see if, let's just try x minus 2. X minus 2. Let's see if that's a factor. So this time for our synthetic division, we're going to use the number 2, because that's what would make x plus 2 0. So let's use 2. All right, so I'm going to bring down my 1. 2 times 1 is 2. Add those together, we get 2. This is 4. Add them together, we get 2. Multiply, that gets 4. Bring that down. 2 times 4 is 8. Negative 8 plus positive 8 is 0. That is a factor. And so I know that x minus 2 is a factor. Okay, so what this answer here in our synthetic division, this was on your test. Remember, it's x to the 3rd plus 2x squared plus 2x plus 4. Okay, so I'm still not really sure of what my what another factor is going to be. So I'm going to go ahead and do some more long division again, synthetic division. I've got 1, 2, 2, and 4. And this time I want to look and see if x plus 2 is a factor. So this time I'm going to divide by negative 2. So I'm going to go ahead and bring my 1 straight down. Negative 2 times 1 is negative 2. That's 0. Negative 2 times 0 is 0. Add those together. That's 2. Negative 2 times 2 is negative 4. Add those together with 0. And there, once again, we have a factor. So I know x plus 2 is a factor. And so now what that tells me is this is x squared plus 0x plus 2. X squared plus 2. Okay, so there's nothing else. I can't factor this out anymore. So I can now see that all of my factors are 3 times x squared plus 2 times x minus 2 times x plus 2. All right, so I want to rewrite this problem real quick so you see it a little bit different. Let's just look at the original. It said f of x equals 3x to the fourth minus 6x squared minus 24. Sorry, my dogs are barking. Hey! Be quiet. Sorry. Okay, so now on this problem, let's factor it a different way. Let's say we can pull our 3's out. That leaves me with x to the fourth minus 2x squared minus 8. All right, I can actually factor that because this is a 4 and this is a 2. I can still factor that. Two numbers that multiply together to get negative 8, add together to get negative 2. Well, I believe that that is going to be 4, negative 4, and positive 2. And so that would be x squared minus 4 times x minus x squared plus 2. All right, and I can see that x squared minus 4 is the difference of perfect squares, so that's going to be x plus 2 times x minus 2 times x squared plus 2 times our 3 that we had already pulled out. So if we had factored it that way, we would have gotten the same exact thing. All right, so there you have it, and we're going to do another problem like that in just a minute. All right, I want to go back and look for a minute at the function that we just worked on. And I want to just kind of review about what we did just a little while ago. We were trying to factor, and so we just kind of took a guess of what a factor might be. And so we said, well, maybe a factor might be x minus 1. And so we set up our synthetic division, and we took our 1, and we did all of our synthetic division, and we ended up, I believe, with like a negative 27. And we said, well, 27 is not a 0, so that means that x minus 1 is not a factor of this function. And so then we guessed something else. We said, okay, well, let's guess x plus 2. And so up here, instead of doing 1, we changed it to negative 2. And when we did the negative 2 and did our synthetic division, we actually did end up with a 0 here. And so we said, yes, x plus 2 is a factor. And then we guessed again, and we guessed x minus 2. And so we did our synthetic division with a 2. And once again, we did end up with a 0 as a remainder. So I knew that these two were factors just by guess and check. But that could get really long and arduous and very difficult because there's any number of choices that I could have made. And it might take a really long time to find this 0. So there is a way that we can narrow that down. And what we can do is we can take, your math book is going to call this last constant p. We can take all the factors of p, and in this case it's negative 24, and all of the factors of this coefficient in front of our leading variable here, which is 3, all the factors of 3, and try all of those, and that's going to give us somewhere in there we're going to find some that end up with 0. And so what we would do is say the factors of negative 24 are going to be plus or minus 1 and plus or minus 24, and then plus or minus, let's see, 2 and plus or minus 12 and plus or minus 3 and plus or minus 8, and then 4 and 6, and those are plus or minuses. And all of that is going to be over the factors of 3. So the factors of 3 are just 1 and 3, so we could have 1/3 plus or minus 1/3. If it was 1, it would just be all of these, but all of them in all of this plus all of these divided by 3. So our choices that we can choose from are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24, and then plus or minus 1/3, plus or minus 2/3, plus or minus 3/3 is 1, so we've already got that one, plus or minus 4/3, plus or minus 6/3, that is 2, and we've already got that, plus or minus 8/3, plus or minus 12/3, that's the same as 4, we've already got that, and plus or minus 24/3, which is 8, plus or minus 8. So you can see there's a lot to choose from, so always take the easiest ones first, okay? So always try like a 1 or 2, something around here, and use the positives and negatives. And if you have to, you might have to keep on going into some of these fractions, but that's the direction that we need to go. All right, so not all polynomials are factorable, but the rational root theorem can help you find all possible rational roots of polynomial equations. So this is the actual textbook definition of what we just did. And so here it is, the rational root theorem. It says, I'm going to go ahead and write it. If the polynomial p of x, and I'm just going to call our polynomial p of x here, is equal to, let's say we had 3x to the 4th minus 6x squared minus 24. Okay, has integer coefficients, so we look at our coefficients, and yes, they're integers. Then every rational root of the polynomial equation, when we set p of x equal to 0, so that we would set this equal to 0, can be written in the form of p over q, where p is a factor of the constant term, so that in this case it's going to be negative 24. It's all the factors of negative 24, and q is a factor of the leading coefficient, and that in this case is 3. All right, so all of that whole string of numbers that we had is what could be a factor of that. Okay, but those are the ones we could choose from. So this is more just the algebraic definition, and this is the actual practical definition of what we just did. So it's all the factors of 24 over all the factors of 3. And they say p over q. The p stands for our constant. I don't know how you could do that, maybe p like that, so it looks like a p. And then this over the q, which is the leading coefficient. So there you have it. All right, let's look at this example to help us use the rational root theorem. It says the design of a box specifies that its length is 4 inches greater than its width. The height is 1 inch less than the width, and the volume of the box is 12 cubic inches. What is the width of the box? So the first thing we want to do is write an equation to model the volume of the box. The question states, what is the width of the box? So let's let width equal x, and then we can let the length equal x plus 4, and the height can equal x minus 1, as what the instructions tell us. So there that is. And next we need to remember what the formula for volume is, and we know the formula for volume is length times width times height. So now all we have to do is multiply those three together, x times x plus 4 times x minus 1, and that tells us that equals 12, the volume, which is 12 cubic inches. So once we have that, we can multiply it all together using our FOIL. We know how to FOIL and distribute. And we end up finding out that it's x to the 3rd plus 3x squared minus 4x equals 12. But remember, in our rational root theorem, it said set it equal to 0. So let's subtract 12 from both sides, and we end up with the following equation. So once we have that equation, Now we still need to find out what x is, so let's see if we can factor it a little bit using our synthetic division and see if we can figure it out. So we could try all day, lots of different numbers to try and using our synthetic division to try and figure out something that would end up with a 0, but we can narrow down our options using the rational root theorem. All right, so step 2 says to use the rational root theorem to identify all possible rational roots. So remember, the rational root theorem says to take the constant, which is negative 12, and divide it by the coefficient of the leading variable, which is the 1. So we're going to find all the factors of negative 12, and here they are written out for us. So what we want to do is we're going to try each of these numbers and see if we can find any that equal with a 0 remainder. All right, so we're looking for a 0 remainder. So always start with 1. It's the easiest one to start with. So let's go ahead and do some synthetic division using 1. We're going to use positive 1 first. All right, and so we're going to put in 1, 3, negative 4, and negative 12, and that's the leading coefficients right here. All right, so remember in synthetic division, you bring your 1 straight down. 1 times 1 is 1. Add those together, we get 4. 1 times 4 is 4. Add those together, that's going to be 0, so we end up with negative 12. That's not very helpful to us because we need a remainder 0. So we're going to erase and try something else. This time, let's try negative 1. See if that's any better. So again, bring the 1 straight down. Negative 1 times 1 is negative 1. That's going to be negative 2. That's negative 6. That's positive 6. Again, we don't have a remainder of 0. We have a remainder of 6. So negative 1, we could just go ahead and cross that out of our list. Or positive 1 and negative 1 gets crossed out. So next, let's go ahead and try 2. See if we could do any better with 2. All right, so we'll try 2. And again, bring your 1 straight down. 2 times 1 is 2. Add those together, we get 5. 2 times 5 is 10. Add those together, we get 6. And 2 times 6 is 12. Subtract that, we get 0. So we know that 2 is a factor. So that tells us x minus 2 is going to be a factor. All right, so now all we have to do, remember this original problem started out with x to the third. And once we divide it by x minus 2, remember it's synthetic division, this changes to x squared. So we are ending up with x squared plus 5x plus 6. All right, and now when I look at this, I can see that I can easily factor that. Two numbers that multiply together to get 6, add together to get 5. It's going to be 3 and 2. It's because 3 times 2 is 6 and 3 plus 2 is 5. So I can say x plus 3 times x plus 2. All right, so the factors of this volume problem are going to be x minus 2 times x plus 3 times x plus 2. And remember, we're always supposed to set it equal to 0. So in order for this to be true, x minus 2 has to equal 0, or x plus 3 has to equal 0, or x plus 2 has to equal 0. So we're going to see that x has to equal 2, x has to equal negative 3, or x has to equal negative 2. Now we know that a width cannot be, let me fix this. We know that a width cannot be a negative number. It can't be a negative 2. We also know that it can't be a negative 3. The only choice then that's left is x equals 2. So our width must be x equals 2. Okay, so let's move on. Actually, that's the end of this video, so why don't you try some delicious and healthy snacks from your kitchen. Take a little intermission, and I'll see you back at the next video. See you later. Bye.